Hey there, fellow space enthusiasts. Ever wondered what lurks at the farthest reaches of our universe? Well, get ready to be blown away, because today we're diving deep into the cosmos to unravel one of its most enigmatic mysteries. Imagine gazing into the night sky and stumbling upon a mere speck, a smudge amidst the vastness of space. But don't let its unassuming appearance fool you. This tiny blob holds the key to understanding the birth of supermassive black holes, the cosmic giants that shape the very fabric of our universe. In this video, we'll embark on an epic journey to explore the awe-inspiring wonders of space. From the mind-bending concept of redshift to the mind-boggling discovery of the most distant black hole ever detected, we'll uncover the secrets hidden within the depths of the cosmos. But here's the best part. We want you to join us on this cosmic adventure. Share your thoughts, questions, and theories in the comments below. Let's spark a conversation and delve deeper into the mysteries of the universe together. Introducing Abell 2744. It's a giant cluster of galaxies around 4 billion light-years away, basically our backyard, cosmologically speaking. The most interesting thing about Abell 2744, at least for us today, isn't what's in the cluster itself, but what's behind it. The cluster lives in a vast halo of dark matter that warps space across its 4 million light-year span. Light from distant objects traveling through the cluster is deflected and magnified. The cluster is a stupendous gravitational lens that enables us to see much further than our puny human-made telescopes would normally allow. That's why the Hubble Space Telescope studied Abell 2744 in detail, and why it was one of the early must-dos for the James Webb Space Telescope. And this is where our smudge got interesting. JWST observes deep into infrared wavelengths and showed that the object has IR colors consistent with a galaxy whose normally visible light has been stretched out by the expanding universe, increasing or redshifting its wavelength by a factor of over 10. Higher redshift means larger distance, and a redshift of 10.1 means this light has been traveling for around 13.2 billion years, coming to us from a time near the beginning of time when the universe was less than 3.5% its current age. That earned our smudge the name UHZ1 for ultra-high redshift galaxy number 1, where the Z is the symbol for redshift. That's cool, but JWST has now found galaxies quite a bit more distant than this. The really exciting moment came when we pointed another orbiting satellite at the smudge. This is the image by the Chandra X-ray telescope. It turns out there are a lot of X-rays coming from this little blob. Now, X-rays are much harder to bring to a sharp focus, so the 4 pixels of X-ray light aren't coming from across this spread-out region, but rather from somewhere inside this region. There's really only one known way for a galaxy to be blasting out X-rays at this level, and that's by harboring a quasar. To refresh your memory, a quasar is when the supermassive black hole, the SMBH, that lives at the center of every galaxy starts feeding. As matter swirls towards the black hole, it's superheated until it outshines the entire surrounding galaxy. And just before it reaches the black hole, conditions get so crazy that the space outside the black hole glows bright with high-energy X-rays. Based on the amount of X-ray light and the distance, we can estimate that the black hole must be 40 million times the Sun's mass. That's 10 times the mass of the Milky Way's own SMBH. UHZ1 is the most distant quasar ever discovered, which also makes it the earliest known quasar, and so the earliest black hole that we actually have evidence for. So with that out of the way, let's get to the good stuff. To understand why UHZ1 is so exciting, you have to understand one of the biggest debates in cosmology, the origin of supermassive black holes. Essentially, every galaxy in the modern universe has at its core a black hole that's 100,000 to several billion times the mass of the Sun. We also see much smaller black holes, so-called stellar black holes, that can be in the rough range of 10 to 100 solar masses. Oddly, we don't see black holes in the middle range of 100 to 100,000. We'll come back to why that's odd. Now, we know how to make stellar black holes. They're what you get when the core of a massive star collapses on itself after the star dies. So how do you make a supermassive black holes grow? That's the big question. Either the black holes started small and grew way faster than we thought they could, or they started much bigger than the black holes that form in stellar deaths in the modern universe. These are the small seed and heavy seed models, respectively. UHZ1 is going to help us choose between them. Can a stellar corpse grow into a quasar engine in less than 1 billion years? Well, it's tricky. There's a limit to how fast a black hole can feed, even with an endless supply of gas. As gas spiraling into a black hole heats up, it blasts out radiation which pushes on the infalling gas and counters the black hole's gravity. Bigger black holes can eat more and radiate more, but there's always an approximate upper limit that increases with that mass. It's called the Eddington limit. You can calculate how big a black hole would grow feeding at this maximum rate for 1 billion years, and the answer is not big enough to explain those early quasars. That said, there are various tricks we can include to make the small seed model work. There are scenarios in which black holes can feed faster than the Eddington limit, although they still need to feed non-stop to reach supermassive status so quickly, which itself is a problem. Or you can form a lot of black holes close to each other and have them merge very quickly. Or you can start out with really big stars, leaving behind black holes that are maybe 100 or even 1,000 times larger than are produced today. The mysteries of the cosmos continue to astound us, from the birth of supermassive black holes to the evolution of stars and galaxies. But our journey doesn't end here. By delving into the fascinating world of space science, we've only scratched the surface of what's out there waiting to be discovered. From the smallest subatomic particles to the vast expanse of the universe, there's always more to learn and explore. So if you're hungry for more mind-blowing revelations and cosmic adventures, don't forget to hit that subscribe button below. Join our community of space enthusiasts as we embark on a journey of discovery together. And hey, while you're at it, why not check out some of our other videos? Dive deeper into the wonders of space science and uncover the secrets of the universe one video at a time. Thanks for tuning in, and until next time, keep looking up.